It is now my pleasure to turn today's program over to Tom Dillon, Application Training and Sales Manager, Miller Fall Protection. Mr. Dillon, the floor is yours.
Dana, thank you very much. Good afternoon, everyone, or good morning to those of you who may be out on the West Coast. As Dana said, my name is Tom Dillon, and I am the North American Application Training and Sales Manager for Miller Fall Protection, a company that I started with back in 1995 and have held many positions with Miller Fall Protection over the years to bring us to today to talk to you about working at height and how we can prevent some of the accidents and injuries that are out there as long as we can get you educated. We can move on to the next slide. Let's talk a little bit about the chilling truth behind leading edge falls and their threats. So to know where we're at today, I think it's always good to look back in the past as a comparison. If you go back to the Golden Gate Bridge construction, which was from 1933 to 1937, there were 11 people who lost their lives. And although the chief engineer for that particular job site was very safety conscious, requiring hard hats and actually building a safety net under the bridge deck, which did save 19 lives, there were 10 lives lost on a single accident when a 5-ton working platform, a crane broke through a working platform and tore down that net. And I think all those lives could have been saved had they used a personal fall protection system versus a collective system of that net that was underneath the bridge. Next slide, please. Did you know that in the 1930s, the average rule of thumb for a high steel bridge construction project was to expect 1 fatality for every $1 million in cost? So if we were to use that same logic today with the bridge that's being built in New York City, there would be hundreds of people that would lose their lives. And that would be unacceptable. And so although these numbers are very staggering, we've come a long way since the 1930s. But we still have a lot of work to do because falls from height are the #1 fatality still in the construction industry. In 1 year's time, approximately 100,000 disabling injuries occur, and between 600 and 800 fatalities are attributed to working at heights and falls. That's about 2 workers a day, every day, including weekends and holidays, all year long. And again, I think it can be completely avoided if the right precautions are taken. Move on to the next slide. Falls from heights are preventable, and that's what we're going to talk about today. So why do we keep seeing these statistics of 100,000 disabling injuries, between 600 and 900 deaths, near misses that happen all the time that aren't necessarily accounted for? And how is it that the construction industry still has the highest statistics for deaths and injuries when it comes to working at heights and falls? I think part of it is the lack of fall protection equipment and the education and training that goes along with that. A lot of it is the proper use of their equipment. That comes from the training and continuous training for those products. It's using the right fall protection equipment for the right application. And we see that quite often that that's not the case. Regular equipment inspections before each use. We can't stress enough to people as they use their fall protection that if they put it on in the morning and they wear it to lunch and then they throw it down on the job site somewhere and then come back after lunch, even though they were only gone during lunch, they really need to take a few minutes to inspect their equipment again, simply because they don't know what could have happened to it over lunchtime. And a lot of times that doesn't happen. And so we find that because of that, some of the equipment is in a condition that probably should be taken out of service. And if someone were to actually look at it, they would probably notice that. But people get complacent in the fact that I wore it yesterday, so it's still good today, and that may not be the case. And then accurate calculation of fall clearance distances. Like I said, I've been doing this for a long time, 22 years, and it amazes me to this day when you can go out and give a fall protection class and ask people who use their shock absorbing lanyards how far away do they need to be to make this lanyard work so that they don't hit something and they don't actually have a proper answer. So again, a lot of that comes from the education and continual training that we need to do with the employees. So what we'd like to do today is get you a little EDGE-ucated on a new application issue that we found over the years in the fall protection industry. And what we're going to touch on is what exactly is a leading edge and what are their dangers, the basics of leading edge self-retracting lifelines, leading edge standard overview, where you'll be able to find where these regs are, calculating your fall clearance distance when it comes into a leading edge application, and leading edge solutions by Honeywell. You can go to the next slide. So what's the big deal about a leading edge? Well, a leading edge is defined as an unprotected side or edge during periods when it is actively or continuously under construction. So, for example, the very picture to the right, as you can see, these gentlemen are putting on a corrugated roof, and their edge is active and continuous. As they put these pieces out, they can have an edge that they can fall off of. And in this particular case, that metal corrugated roofing is actually quite sharp. And so we have to be careful of the fact that, they don't have an overhead anchor point. It would be behind them and lower than them. So more than likely, if they were to fall off, they're going to hit the edge of this application. But the second part of this is also extremely important, is that it's any application where a lifeline of the user's connecting device has the potential to come into contact with an edge. When you actually add that part into it, well, there's a lot of people that might actually have fall protection products that would come into contact with an edge. They're actually everywhere. They're in construction, they're in maintenance, they're on scaffolding, people in warehouses when they're using their fork trucks and lift trucks. Things of that nature. Anytime you can have a connecting device potentially hit the edge of something, it's a problem, because traditional lanyards and traditional self-retracting lifelines were not designed to fall over the edge of something when they're being used. And more often than not, almost every single time we do the testing, they will sever. And we've estimated that almost 80% of all of the working at height applications could either have a leading edge or a foot level tie-off, which if you have a foot level tie-off, more than likely you would also hit the edge. So we think that this is a very common application that people are overlooking, and we wanted to make sure that we have some education for people out there to be able to use the right products in the right applications. We can go on to the next slide, please. So how would you protect yourself against leading edge dangers? One, you have to know where your edges are. You have to open your eyes to a new set of rules, if you will, for what you're looking for fall protection. And edges are everywhere, like I said. If you are in a articulating boom or a scissors lift, the potential of you falling out of that, even if you're connected to a harness and a lanyard, you'll actually be falling over the edge of that railing. That is an edge. It may not be an extremely sharp edge, but it is still considered an edge. If you're on scaffolding, you fall off of scaffolding, it still has an edge. So again, it might not be the sharpest edge, but it's still an edge, and connecting devices are not designed to be able to do that. So you really need to look around and decide what you have and where you have them, because I think you'll find that there's a lot more edges where you hadn't noticed them before. So you want to make sure that you're using a leading edge rated connecting device anytime that the lifeline has the potential to come into contact with an edge, and or if you're anchoring off at your feet. Because again, the odds are if you're anchoring off at your feet, you'll be working somewhere where if you were to fall, you would fall off and that connecting device might hit the edge. A leading edge connecting device has extra shock absorption that's built right into it, and it is part of the regulation. So I put a little snippet in there for you so that you can read it. The connecting device has to have the shock absorption on the end attached to the user so that it will reduce the force on the lifeline itself as it hits the edge in the event of a fall. It keeps the lifeline intact, so not only does it take some of the force off of the edge, but it helps reduce the force if were you to get a swing fall. And it also reduces the force that's actually on the user themselves. It will save someone's life if it comes to falling over the edge of something. And all edges can be measured. There are radius gauges out there of many different kinds that you can use to check to see how sharp an edge actually is. And the reason why that's important is what we're going to talk about here in our next slide. Because of the standards, we'll go to the next slide. ANSI Z59.14 in 2014 has self-retracting device and personal fall arrest and rescue systems. And it defines, and it was developed in 2012, it's published in 2014, basically to have a legitimate self-retracting lifeline rated for leading edge, you have to test it on an extremely sharp edge. It has to have a radius of a 0.0005 or 13 millimeter. It is razor sharp at that point. So anytime something hits that edge, it may, if you test it perpendicularly, test well in that particular case. But as most people know, when you fall, even if you fall directly straight underneath what you're attached to, there's going to be motion, there's going to be some swing. So you'll actually get a lateral slide, and in many cases, that sharpness of that edge that it's tested on will cut a piece of webbing or even cable that's not rated for leading edge. The leading edge testing is conducted both perpendicular to the edges as well as an offset laterally along the edge to ensure the lifeline will withstand the sliding along the edge during the fall. It must include an integral shock absorber, as I had said earlier, attached to the end of the lifeline connected to the worker. Now, for our friends up north in Canada, there's actually two different regulations at the moment that are kind of fighting. You have the Z259 2.2 from 98, which basically defines what a self-retracting device is. And it's basically designed for anything that would be working overhead, and it had no intention of anything coming in contact with an edge. CSA 259.22.17 for retracting devices, published in 2017, includes a new classification for self-retracting lifelines that includes a leading edge self-retracting lifeline. So those would be an SRL-LE there. The leading edge self-retracting lifeline is classified as being suitable for the applications that has one or more of the following conditions, in which the SRL is anchored lower than the elevation of the dorsal D-ring. So again, like I said, maybe at foot level. Or its extracted lifeline can bear against the edge or the surface during the fall. In this particular case, they've decided to use the radius of a 0.010, which is a 25 millimeter, which, as you can tell from what the ANSI standard is it still can be considered sharp, but it is not as sharp as what ANSI is testing to. And at the moment, CSA is not yet testing or certifying products to this particular standard. And then for anyone who might have counterparts that are in Europe, Europe also has a leading edge standard. It was from 2013, and their radius is actually at a 0.020, which is a 50 millimeter, which is even more round than what Canada or the US is testing at. But again, for us here in the US and for ANSI, if you want to meet that standard, I think they did a good job in determining that if we test something to the absolute sharpest that something can be, and that's what the case is and it works, then we know if it's not quite that sharp, we'll still be in a good position. So I think they did the right thing here. If we can move on to the next slide. The big thing with leading edge is that you're going to have to increase your fall clearance calculations, and you're going to have to make sure that people using a leading edge self-retracting lifeline also know how to calculate those fall clearance distances. The first thing you always want to do is you always want to refer to the product manuals, the instruction or user manuals. Different manufacturers' products work differently. So you always want to check with the manufacturer of the product that you're using to make sure that you're using it properly. If you change products, if you change manufacturers, don't just go by what you did before. Definitely check with the manufacturer on how the product would actually be used. Always refer to the product label for minimum clearance distances. Part of the ANSI regulation is that those distances have to be on the unit themselves with either a minimum or a maximum to be able to tell you this is what you have to be able to use it at. You need to try to minimize your swing fall. So I tell people all the time when we give training classes, you can take a 50-foot self-retracting lifeline leading edge unit, climb up, and walk away from that unit 50 feet. And if you were to fall at that point, you could still potentially hit the ground if you were not 50 feet up off of what you walked out 50 feet away from. So again, we always want to try to minimize the swing distance if we can help it. So again, if you have a 50-foot self-retracting lifeline and you're working in an area, instead of walking out horizontally from that unit 50 feet to work, it would probably be best to take that unit down, walk across the ground the 50 feet, and then walk back up in the area that you need to work to put the self-retracting lifeline back up. Completely minimizes your swing fall, reduces the clearance distance that you need, takes a lot of the guesswork out of it in the process. All leading edge units have new terminology that we're using in the industry, which, for example, would be the setback distance. And that's the distance perpendicular to the edge that the SRL is anchored back from the edge. So again, the drawing that's in the top right corner of our screen, you can see that would be the distance directly back from where you would have your anchor point. And then you have a lateral edge distance, or your working zone limit. And so again, that's going to be the maximum distance parallel to the edge that the user can walk away from the point where the SRL is actually attached. And so as you can see, that would be the lateral edge going to the right from where the anchor point is as you would come out. So if you wanted to, if you look down to the right corner, where we actually have an example of the Triple Light Extreme unit and the minimum fall clearance required. If you went down to, let's just say your setback was 3 feet, and then you went across that you had a 3-foot lateral edge that you would have for working, you would actually need a 16-foot fall clearance for this system to work. So in a lot of cases, although you have a great self-retracting lifeline for leading edge, you may not have 16 feet from what it is you don't want that individual to hit. And if that's the case, you might need to figure out a different place to anchor it. You might want to anchor off higher if you can. You might want to anchor off back farther on your setback distance. There's a lot of things you can do to modify, as you can see through the chart, what some of the distances are. But again, if you look, you know, you can have it down as minimum as 14 feet, and, you know, it can go up as much as 20 feet. So, I mean, there's a lot of distance there in 6 foot for a user for that product. You have to keep in mind product maximum weight capacities, as well as the user's weight that's going to be using the product. So we can go on to the next slide. So some of the leading edge solutions for these, just so that you know some of the products that are available. Go to the next slide. You have on the very left a personal fall limiter. So again, the smaller self-retracting lifelines that individuals would actually wear. They would, in these particular cases, have the shock absorption attached to the units themselves, and the snap hooks or rebar hooks would be hooked away from them. So going over the edge, you would have the PFLs go with them so that their deceleration devices are on them as they go over the edge. In the center, you would have your self-retracting lifelines. These are both a welding and a non-welding application. And then we also have another unit, the Mighty Light self-retracting lifeline leading edge at the end for a more harsh environment. So again, these would be used either more in your setback distances. They would be hooked to your anchor point, where the snap hook would be attached to the person. So you can see in this particular case, when it goes over the edge, the unit itself stays, but the shock absorption is attached to the individual's back. So you have to make sure that you're using the right product in the right application. As we move forward with these products out in the industry, we want to make sure that there's no confusion. Many of them look very similar to products that are already out there that are not leading edge. And in some cases, workers will see one person using a product a certain way, they'll want to use their product that way, but their product isn't actually built to be used that way. So like I said, the education is extremely important, that we make sure that if we have leading edge applications, that we get people the right products, that we educate them on the right products, and that they use those products correctly. So we can go on to the next slide. And that was a very brief, quick overview on the leading edge applications and leading edge products that are new to the industry. We'll be more than happy to answer any questions for anyone. And if you have questions or issues that you'd like someone to come out and see, you can get with your MSC sales rep, who can get with a Miller Fall Protection Honeywell rep, and we can come out to help.
Tom, thank you very much for that education. It was very, very informative. Good afternoon, everyone. My name is Rebecca Avery, and I am the Digital Merchandising Manager for the Safety Product Line at MSC. Again, thank you, Tom, very much, and Honeywell and Miller Fall Protection. That was very informative and very different from what we know out in the industry about fall protection today. I just wanted to let everyone know, as a safety professional in the manufacturing and construction industry, it's your job to ensure a safe, hazard-free work environment every day. To help with that, MSC has established our Better MRO site. This site is an educational site where you can learn about fall protection, PPE, facility safety, and other things that are going on in the industry. It's full of original content and content such as this that is, you know, licensed from our manufacturing partners and our industry experts. Just want to let you know that a copy of this webinar will be recorded and put up on Better MRO so you can share with your customers and your colleagues in the future. Again, that URL is mscdirect.com/BetterMRO, and you will go onto the safety site. Again, I'll send out a link to the recording of this webinar at the appropriate time. And now we'll open up the floor for questions.
As a reminder, if you'd like to ask a question via your web console, locate the Q&A panel on the right-hand side of your screen. Type your question in the open area and click Send to all panelists to submit. If you'd like to ask a question over the phone, simply press *1 on your telephone keypad and you'll be placed into queue. Again, that is *1.
And Tom, while we're waiting for questions, this is Rebecca again. I actually have a quick question. Is there any kind of specific labeling, whether it's an anti-labeling or some kind of infographics that's on the actual product itself that would indicate that it's a leading edge fall protection piece of equipment versus a regular fall protection piece of equipment?
Yes, and that's a fantastic question. Actually, there is a graphic that should be on every piece of leading edge equipment that it looks like the corner of an edge with a, for lack of a better word, a rope going over the edge of it to indicate that this is designed to be used for leading edge applications.